So, in the previous video we see how to make the movement of our character, and in this part we will see how to make the enemy AI, and I've did a little bit of changes. So we will go about two phases for our 3D beat'em up over here. One will be to have basically what we saw in the previous video, where we can move around, and one when there is actually enemies, where the camera just stops, it holds a player inside the view of our camera, and we spawn enemies so that of course we have something to attack. Okay, and when we kill all of them, we reset back to the previous phase and then move on until the next trigger, where we trigger the other wave of enemies, and so on. So pretty much what we had on arcade games. Okay, so let's start. Now let's take care first, let's see the logic first for spawning the enemies. As you see, there are a few cubes over here, both to the front of our character and both to the back, and those are our spawn positions. Okay, we have them under all the same game object, and we have a new script that follows the camera holder, since let's see it a little bit. Since we do not want to spawn inside the view of our player, we have it to follow, instead of following the player, because we lerp the camera holder to the position of the player, we want it to have the exact same position of the camera holder. Okay, you will see that if I move, now it cannot move since it follows this player. So you see that if I move the camera holder, it will actually move both our spawn positions, but it will only follow it in two axes. So if the player is towards the edge, the spawn positions will still remain at the same position, at the same x axis. This is the x over here, since this is the z. Okay, so otherwise, if the player was towards the edge, some people will spawn, and you know, it will spawn in the air and it will fall down. Now, as you see here, they do not exactly touch the ground, since we're using the navmesh agent. The navmesh agent automatically takes the spawned enemies, or any agent for that matter, and it will place him upon the navmesh map. Now, the same way goes with the colliders that block the movement of our player. Okay, all this stuff just moves around. So these colliders is for our player, so that he doesn't go out of sight when the camera is not moving, so that he does not go out of view of the camera. Okay, pretty simple. Now, one thing to keep in mind: these block colliders are on their own layer, block colliders, and all enemies are on the layer of enemies, of course. And then we need to disable collisions between the enemy layer and the block colliders layer, and the way you do that is go to Edit, Project Settings, Physics, and you will see over here, okay, we disable the collision between block colliders and enemies. Now let's see the pretty basic script that follows the game object, but on two axes. Okay, target, we need to store the original X. We store the original X, and then the transform position will be a new vector 3 with the original X and the target's position Y and the target's position Z. Okay, pretty simple. And then we have also created a game manager that holds all our spawn positions, the enemies that are currently spawned, okay, the rate maximum and minimum, so it's random how many enemies they're going to spawn. Of course you can change that. Okay, the script that moves the camera so that we can enable and disable it, and then the prefab for our enemies to spawn. Now let's see the game manager. Okay, prefab, the follow object script that we created on the previous video, on the previous part. Spawn rate maximum minimum. Okay, you understand that. An array of spawn positions. This does not need to be a list since we do not update dynamically the positions. Okay, it will be you can use a list, but since we do not have to, let's just use an array. Okay, we have a list of a list for the enemy spawn since we want to remove and add new enemies. Okay, a boolean that starts all the logic to spawn enemies now. If we want to hold the player, okay, and if spawn enemies, hold player equals true, so the camera stops moving, therefore our player cannot move towards outside of the camera. Okay, the function to spawn enemies. Okay, and we close the boolean. Now of course you can have this all as a simple as a function and call that instead of doing the boolean, but with this you can do it from the inspector straight ahead, you know, for debugging purposes. So if hold player, we disable the script. Now we do not disable the game object, this is the follow object script. Okay, so it disables the functionality, it disables the script, so the script doesn't run. Then if hold player is false, then the camera mover we enable. And then to disable the hold player, the best way to do it is to see how many enemies are spawned right now, and if it equals 0, so there is no enemies, then we let the player move again. Okay, pretty simple. Now the spawn enemies. So this function, we have a random value for a integer since we want it to be random. Okay, we call a random.range from spawn rate minimum to spawn rate max plus 1, so that it's actually the spawn rate max we add in the inspector. And then in a for loop we say so I equals 0, I lower than the random value, then we start adding to the I. Now random spawn, we need to take random positions to spawn for every enemy we want to instantiate. Okay, and here where the instantiation happens. So game object geo, instantiate the enemy prefab, spawn position on the random spawn position, the rotation dot identity. Okay, we do not care about the rotation over here since we do it from the enemy AI anyway. And then we need to cast it as a game object. Then we go to the list of enemy spawned, and then we add this, the game object, the new game object that we instantiated. So this is the game manager. Now of course because we want to access it from a different game object, we also have the tag of game controller. And then for our triggers, now you see that you only need you can have triggers at whatever place you want. Okay, doesn't matter. So there are trigger script that spawns our players. We have reference to our game manager. We find the game manager and take the component of game manager, okay, based on tag game controller, and then on trigger enter, if the collider other that enters a trigger, if it has the component of player input, then we go to the game manager and we say spawn enemies now equals true, and then we destroy the game object. If we do not destroy the game object, it will keep instantiating new and new game objects. So this is the trigger game objects. Okay, we said about the colliders. Okay, the block colliders should also follow the camera holder. Spawn positions also follow the camera holder. Okay, don't forget to add the spawn positions on your game manager, and don't forget to add the enemy prefab and the camera mover, where basically the follow object script into a camera mover over here. And then the only thing left to see is the actual enemy AI scripts. Let's see our prefab. We have our prefab over here. We talked about the animator in the previous video. Okay, we share the exact same animator as our player, so there is no point in retailing all of it. And let's see the components for our enemies. Okay, rigid body. Keep in mind that the rigid body is kinematic, and since it's kinematic, you do not need to constrain this. Okay, capsule collider, this stuff. Now mesh agent. Okay, speed, set it to 1, or whatever you feel that it looks more natural. Okay, and then the character stats, which we say in the previous video why we had to add the character stats over here, and then the enemy AI that we're going to include. So the logic behind all this is, now keep in mind that this also has a damage collider, same as the player. Okay, and we enable and disable the damage collider, if you remember, by animation events based on where we've set the keyframes. Okay, we did all that in part 1, so if you follow that, then you have everything. So what I was saying, don't forget to add the damage collider. And then on our enemy AI, let's take a closer look. But first, let's talk a little bit about the logic behind this AI. Now, this is going to be pretty basic. Go towards your target, wait till the attack rate is wait for your attack rate, and then start attacking. Okay, you can take some more examples like the videos on Assassin's Creed, on that fight system, and you can create a ticket system so that not everybody attacks at the same time. So yeah, decide what you want to do. That's all depend on the game design you want to make. Okay, so of course this is pretty much a rudimentary AI. So let's see it closer. Attack rate. Okay, the public attack rate, so that we can set it up. The float, the internal values basically. Okay, how close you need to be on the enemy before starting the attack, the whole attack logic basically. How fast you can rotate. Okay, and the damage collider. We need to set up the animation, the animator, the nav agent, the target, which is the player basically. Okay, if you have 2 players, you have to add more logic to it, and if the enemy is looking left. So we set up the references. The stopping distance of the agent will be the attack range, of course, and we do not want the agent to update rotation. If the navmesh agent was updating rotation, then the player will look, or not the player, the enemies will look on towards rotation that we do not want. So it will not look that it won't be wrong, but it will not look just like the sprites in arcade games, in the old arcade games worked. Okay. The target, of course, is the player, so we can find him by the tag of player, and of course, don't forget to set up the tag for the player. Then on update we need to check the distance, okay, from our position to the target position, and then if the distance is lower than the attack range plus 0.5, therefore because these are floats, okay, you do not want, if it's, you do not know if it's going to pass the distance threshold before starting attacking. Okay, this will avoid some trouble. You will see it, remove it, and you will see what it does. Okay, so if we are at the attack range threshold, then lower than the attack range threshold, the attacking start attacking, else attacking equals false. Now if we are not attacking, we want to resume the agent since we are stopping it when we are attacking, and we want to set the agent's destination to be the target dot position. Let's now we need to find the relative position towards our target, and we do that by inverse transforming the direction of our desired velocity. Okay, and we take basically two values we can use on the Z and on the X, okay, horizontal or vertical, and then we pass that to the animator values, and then our blend tree works pretty much how we want it to work. Okay, so to know if we have to look left, we take the target position, the player Z, and we say if the player Z is lower than our own Z, so on world positions, if the player is before our enemy, then the enemy has to look left. Okay, this is an if statement, of course. Okay, and if it's not, then it will return false. We set up at first the target rotation to be whatever we have over here, and then if we have to look left, we take the target rotation. Now keep in mind that this Z and Z will work because we have the Z is over there. If the Z was at this point, okay, if all the whole world and our characters look that way, you have to compare between the two axes. Okay, so if we have to look left, then we take the target rotation. Since we know what exactly rotations we want to use, we can pass it directly like this. Okay, 180. Otherwise, the target rotation will be pretty much all 0, 0, 0, or you can use identity. And then the only thing left to do is basically a spherical interpolation for a transfer rotation from a transfer rotation again, okay, to the target rotation, and all that by time dot delta time multiplied by rotation speed. Else, the else is if we are actually attacking. We stop the agent, we find the relative position once again from the desired velocity, and this don't actually have to do anything, but since we are stopping the agent, that means the desired velocity will be 0. So all that will simply pass 0 to the animator values, and then they will instead of hard coding the 0, this way it will pass a more fluid movement. Now this, of course, you could just hard code it like that, but anyway, since it works, yeah, this is not wrong, just more complicated than it should, but basically it's a copy paste of this. So since we are at the distance to attack, we take the internal attack float and we start adding by time dot delta time, and if the attack rate if the internal attack rate is higher than the attack rate we set it up, then we set the animation set bool attack to true, And then we start a close routine to close the attack, and of course set the attack timer to 0. The coroutine to close the attack will be yield and wait for seconds. Okay, for 4 seconds, 4.4 seconds, and then we close the boolean of attack from the animator. Okay, now open damage collider, close damage collider. It's exactly the same that we did on the previous video. Okay, damage collider set active true, damage collider set active false. These two public functions are called from the animation events. Okay, and that's pretty much the enemy AI scripts. Don't forget to set up all the references for the enemy over here. This is the player, the enemy is over here. Okay, and then create him as a prefab and delete that, and you pretty much have a working prototype for a pretty basic game like all the old arcade games you have. Now of course you can add a lot more things. Now if you see here, the spawn point can actually show, so you can be and of course it's pretty much a little bit difficult, and of course they hit each other. So as I said in the previous video, you need to add a little bit more checks to see what they are actually hitting, or you can keep it that way. You can do of course whatever you want. So that was it for this part. If you like the video, don't forget to subscribe, like. We have a lot of videos in this channel, so of course I'm pretty sure you can find something you like. And also, if you like videos like this and all the other stuff we have on the channel, then do consider supporting me. The ways you can support me is either on Patreon, or you can pretty much buy a complete project that I've set all things up. Okay, and then you can start prototyping your own game. Check the description for all the associated links. And as I said, with Patreon, with $5 or more, you can get access to a Google folder where I have all the scripts from the channel. Or you can, if you want only one project, so for instance you want this one, you can buy it directly on Gumroad. So I'll see you next time.